Okay, in this video we will explain how to compute the asymptotes of a rational function. Let me remind you that a rational function is a function that can be written as a polynomial over another polynomial. And let me start by graphing this function, which is a rational function, 1 over x. In this case, the numerator is a polynomial of degree 0, and the denominator is a polynomial of degree 1. And we can see that if x takes values like 10, the output is 1 over 10. If x takes values that are big, the outputs are going to be small. Then this graph looks like this. And f of 1 over 100, 1 over 100 is very close to 0. And this is just 1 over 100, which is just 100. Then it's not difficult to see that the graph of this function is like this. And here we can see that this line, which is a horizontal line, y equals 0, is a horizontal asymptote. And the line x equals 0, this is a vertical line. X equals 0 is a vertical line. This is a vertical asymptote. Then this is an example of a rational function that has horizontal asymptotes and vertical asymptotes. What happens if I change x with x minus 1? Let's suppose I consider the new function g of x equal to 1 over x minus 1. In this case, the numerator is a polynomial of degree 0, and the denominator is a polynomial of degree 1. And the graph of this function g is just moving this graph to the right 1 unit. Then in this case we have x equal 1, and then the graph will look like this. Notice that g of 0 is negative 1. This is the point 0, negative 1. And it will be something like this. Then in this case, for this function, the vertical asymptote is the equation, is the line x equal 1. Notice that x equal 1 is to be viewed as a vertical line. And the horizontal asymptote is the line y equals 0. Okay, let's see what happened in general. Notice that this x equal 1 has to do with the solution of making the denominator equal 0. If you make the denominator equal 0, you get x equal 1. Here, if you make the denominator equal 0, you get x equal 0. And let's see what happened in general. Then horizontal asymptotes are easy. Let me just say the rules for horizontal asymptotes. Then we can see 3 cases. Case number 1. If the degree of P is bigger than the degree of Q, then there is no horizontal asymptote. Or let's say there are not horizontal asymptotes. The second case is if the degree of P is smaller than the degree of Q. Remember that P is denoting the numerator and Q is denoting the denominator. Then in this case, we have a horizontal asymptote, which is y equals 0. Remember, this is to be viewed as a horizontal line. Then there is only one horizontal asymptote if the degree of p is smaller than the degree of q. Notice that that was what happened here for this function. The degree of p is 0, the degree of q is 1. Then we are in this situation, and we knew that this is a horizontal asymptote. And the third case is when the two degrees are the same. If the degree of p is equal to the degree of q, then the line y equal leading coefficient of p over leading coefficient of q, this is a horizontal asymptote. And I will explain this a little bit more in detail. Okay, let's do some examples. If you have f of x equal 2x squared minus 3x plus 1 over 500x minus 2. In this case, horizontal asymptotes, the degree of p is 2 and the degree of q is 1. Then we are in this situation, and then in this case we have that there is no horizontal asymptotes. Let's do another example. If f of x equal 2x to the 5th minus 7x to the 4th minus 17 over 3 minus 2x cubed plus 7x to the 5th. In this case, the polynomial is 2x to the 5th minus 7x to the 4th minus 17, and we see that the degree is 5. That's the highest exponent of the x, and the leading coefficient is that coefficient that goes with the highest exponent. In this case, the leading coefficient of p is 2, and for the denominator, the degree is also 5. Then we are in this situation, and the highest coefficient is x to the 5, the highest term is this part. The leading coefficient here is 7. Then the line y equal 2 over 7 is a horizontal asymptote. Let's see another case. If you have f of x equal 3x to the 4 plus 3x minus 7x squared plus 4 over 3 minus 2x to the 5th plus 16x squared. In this case, we have that the numerator has degree 4, the highest degree is an x to the 4, and the denominator has degree 5, this is the highest degree. Then we are in this situation, the degree of p is smaller than the degree of q. Then this function has a horizontal asymptote and is the x-axis. The horizontal line y equals 0 is a horizontal asymptote. Let me just do another example. We have f of x equals 2x squared minus x minus 14x cubed over 3 minus 2x minus 4x cubed. In this case, the degree of p is 3, the degree of q is 3. Then we are in this situation. The leading coefficient of p is the coefficient of p, the leading coefficient of p, which is negative 14. And we have that y equal negative 14. And the leading coefficient of q, of the denominator, is negative 4. Then we have that this is a horizontal asymptote. In this case, this is 7/2. Then y equal 3.5 is a horizontal asymptote. Okay, this is how we compute horizontal asymptotes. They are very straightforward. Let's see what happened with the vertical asymptotes. One observation is that, as you notice, horizontal asymptotes, there are two possibilities. Either there is one horizontal asymptote or there are no horizontal asymptotes. But let's see the vertical asymptotes. Vertical asymptotes, then case number one, if f of x equal p of x over q of x is simplified. This part may be difficult to check, but essentially it says that you have factor completely p and you have factor completely q, and you can see that there are no terms that cancel out. If this rational function is simplified, then the horizontal asymptotes sorry, we are talking about vertical asymptotes. Then the vertical asymptotes are x equal to x1, x equal to x to k, where x1, x2, and sk solve the equation for denominator equals 0, q of x equals 0. Then essentially, once you check that your rational function is simplified, to find the vertical asymptotes is equivalent to solve this equation. Notice that this equation may have no answer in the real numbers, and for that reason, you may have the case in which there are no vertical asymptotes. Let's see some examples. If you have f of x equal x minus 1 over x squared minus 4. In this case, you can factor this one, but you can see that there are no simplifications taking place. Then this is simplified. And then to find the vertical asymptotes, I have to solve the equation denominator equals 0. In this case, we have x squared equal 4, and then x is equal to plus or minus 2. And therefore, we have that x equal 2 and x equal negative 2 are vertical asymptotes. That means that in the graph, here in negative 2 and 2, this graph, the graph of this function, is approaching these lines either on top or in the bottom, right? When x is close to negative 2. Let me do vertical asymptotes. Let me do another example. If we have f of x equal x cubed minus x plus 1 over x squared plus 4. In this case, you can check that this is simplified, but to find the vertical asymptotes, I have to solve this equation, x squared plus 4 equals 0. And here we notice that for any real number, this is never true. X squared is positive or 0, plus 4 is never going to be 0. Then in this case, we have no vertical asymptotes. Let me do another case. Here I forgot to mention that you can consider case 2. If it is not simplified, then you need to simplify. You need to factor and simplify it. Let me do another example. If we have f of x equal x squared plus 3x minus 4 over x minus 1. In this case, we can think that x equal 1 is a vertical asymptote, but then we have to see if it is simplified. Let's see if we can factor the numerator. F of x is x plus something, x minus something over x minus 1. And here we have 4 times 1 is negative 4, 4 minus 1 is 3. And then that means that f of x is, this cancel out, is x plus 4. Then if we want to do the graph of this function, we notice that here is 1. The value of 1 would be 5. 1, 2, 3, 4, 5, right? And when x equals 0 is 4, this is aligned with the slope 1. And then you may think that it's like this, right? Aligned with the slope 1, y equal x plus 4. But we notice that if I ask, or if we wonder what is the domain of this function, then the domain are all the numbers except 1. 1 is not allowed. You are not allowed to have a denominator equal 0. Then you cannot take x equal 1. Then the domain are the points from negative infinity to 1, union from 1 to infinity, and excluding x equal 1. That means that this point is not part of the domain, and that for that reason this point is not part of the graph, and then you usually do something like this. Then the graph of this rational function would be this, right? It's a line, and in this case there is no vertical asymptote, right? Remember, if it is simplified, you just solve the equation, the denominator equals 0. And if it is not simplified, then you have to simplify first. Okay, let's do another example. What about if you have f of x equal x squared minus 4 over x squared plus x minus 6. Let's see if we can simplify this. X squared minus 4 is x minus 2 times x plus 2, and x squared plus x minus 6 is x plus something, x minus something, and here we have 3 and 2. That means that the function f of x is x minus 2, x plus 2 over x plus 3, x minus 2. These two cancel out. And then we have that this is x plus 2 and x plus 3. This is the function already simplified. Then the vertical asymptote is, you need to solve this equation, x plus 3 equals 0. To find the vertical asymptote, you solve the equation denominator equals 0. Then in this case, we get x equal negative 3. The vertical line x equal negative 3 is a vertical asymptote for this rational function. Okay, notice that if I wonder about what are the vertical asymptotes, the horizontal asymptotes for this one, the horizontal asymptotes are easy. In this case, this is a polynomial of degree 2, this is a polynomial of degree 2, the leading coefficient is 1, and the leading coefficient is 1, then here y equal 1 is a horizontal asymptote. For the vertical asymptotes, you have to simplify first. Notice that if you simplify, you will get the same answer in terms of horizontal asymptote. What is the horizontal asymptote of this function, of the rational function? Degree 1, degree 1. Then we have to look at the leading coefficient. The leading coefficient of the numerator is 1, and the leading coefficient of the denominator is 1. Then again, we get the same answer. It's a horizontal asymptote. Okay, this is how you find asymptotes of a rational function. And this is it for this video.